Not all languages are equal. Not all agents are trained in the same way. So a Claude might be trained better on certain high-resource languages, and then there may be some specialized LLM sitting inside some companies' servers. You never know. Between low-resource and high-resource languages, there's a difference, and between builders who are at high levels of abstraction versus those who are at low levels of abstraction, there's different levels of use that you can foresee for AI agents. I think that even this will be negotiated. I think,
hey, I'll finish my task faster, which inadvertently has introduced a lot of technical debt into the system. So it's a fine balance. What we are doing effectively within the teams here, and then you may have some advisor on that as well. We are encouraging people to use these tools, but we are also telling them that you have to understand the code.
I still think that context engineering is an art and not a science. So it's not like it's a magic silver bullet or the panacea to solving all the problems that agents are not good at today.
Yeah.
So to that extent, the human is still involved in pretty much every part of the software engineering lifecycle.
The future is not arriving in headlines. It is being engineered across industries. Aerospace is evolving. Defense is modernizing. Industries are becoming autonomous. Clean tech is becoming scalable. Semiconductors are powering a new computational era. And beneath it all, a new layer of intelligence is quietly transforming how systems think, decide, and adapt. At Tetris Innovations, we don't just talk about technology in isolation. We explore how disciplines converge, how software meets hardware, how policy meets capital, and how intelligence becomes infrastructure. This channel brings together subject matter experts, policymakers, investors, founders, and industry leaders who are shaping the next industrial chapter. We go beyond buzzwords, beyond hype cycles, beyond surface-level analysis. We examine what is scalable, what is defensible, what is deployable at national and global scale. From deep dive podcasts to sharp fireside conversations to hands-on sessions and technical breakdowns. If you're building, investing, governing, or engineering the future, this is your forum. This is Tetris Innovations, where industries evolve and intelligence connects them. If you've landed here directly, watch our 1-minute introduction first, because this isn't just a podcast, it's a front row view of how industries are being rebuilt. And Season 1 begins with the defining shift of this decade: AI, GenAI, agentic systems. Not hype, infrastructure. Software is no longer just written, it's orchestrated, built with intelligence embedded. So we ask, are agentic systems rewriting engineering? Can leaders build without code? What happens when AI becomes your teammate? To start this journey, I couldn't think of anyone better. From core engineering to a decade deep in AI and data science, he understands machines and models. Rajesh, welcome to Season 1.
Hello and welcome you all to our first episode of what is going to be an exciting series of conversations that we're going to have. Those of you who have stumbled upon this video to begin with, I request you to go to the sources. You will find a link where we have given a view of how we see these conversations emerge. We would want to be covering technology at a higher level, innovation being at the center of all of this. But as a season starter, we will be talking about AI, GenAI, and more specifically to talk about the trending things today, which is AgenticAI. We have Rajesh here with us. Rajesh, welcome to the show. It's a privilege to have you here. You have been a domain expert when you start off your career. The first 10, 12 years of your life, I think, was you working in very, very specific knowledge industries. And then over the last, a decade, I think you have become a practitioner from a very data science, standpoint. Just give us a little bit of a view of how your journey has been.
Thank you so much, Ullas. It's first of all a pleasure and an honor to be on this podcast. Thank you for inviting me over to this. As you have mentioned in the introduction, we've known each other for a long time, for the better part of 25 years. So it gives me the greatest of pleasure to be here and to be a part of this new set of podcasts that you're kicking off at Tetris. In a nutshell, my career has had about 3 phases. The first part of it, immediately after graduation from RV College of Engineering, where we studied, was, I would say, the core mechanical engineering and manufacturing part of my career. This was probably for the first few years of my career, up until probably 2007 or 2008. I had a chance to work with one of the best known tractor manufacturing companies in India, and also one of the best known Indian manufacturing firms, that is an MNC, TAFE and L&T. Those were my initial launch pads for my career. Subsequent to that, I had an opportunity to work in the trucks and off-highway equipment space at Caterpillar, and then in the passenger vehicle space at Ford. All these experiences were very formative in teaching me about the underlying statistical and data layer that underpins all of engineering. And thinking back to those experiences, I think it's around 2015 that there was a transformation in my career, going from being originally a practitioner of quality engineering and quality management to becoming a data science professional, right? So this synthesis of a new career, it did not happen in a day. I would say that it was a journey of around 7 or 8 years in the making, starting from statistical engineering. And just to give you a lay of the land of how the technologies and things were back then, 2007 or 8 was when multi-agent systems were being talked about. And this was in the literature even before something called AI was even taken seriously, because you had AI back then in the form of convolutional neural networks in 1999. Jan LeCun had already come up with it. And fast forward a few years, in 2011, AlexNet would happen. But this was before that time, and there were practitioners like Melanie Mitchell at the Santa Fe Institute, and there were many other practitioners out there who drew upon the work of other chaos theorists and other theorists in the 60s and 70s and built a body of work called complex systems theory. And this was an interesting phase in intellectual exploration for me around 2007-8. And fast forward to a few years later, I found myself using optimization techniques a lot in different aspects of my work, right? In a nutshell, 2011 until 15 was a phase in my career where I was exploring not only optimization techniques but also distributed data systems. Hadoop had come out a few years prior with, you won't believe it, but Arun C. Murthy from computer science, RV, was heavily involved in that revolution.
He was part of the Yahoo project, and that got spun off as Hadoop.
Exactly. So there's another little thing there that links us back to RVC from Hadoop. But fast forward to 2012, 2014, the scene at the time was data scientists are going to be the next big change makers in the industry, right? And that pattern sort of carried on, and it evolved through many phases, I would say. I think it's fair to say that data science has morphed into AI, and AI has morphed into generative AI, and that same thread or that same revolution continues until today in 2026, where we are seeing agentic AI come to the fore. So in the last 10 years of my career, so from 2015 or thereabouts, when I moved into data science until now, the first few years were spent in consulting. And this was an exciting space to be in the consulting area, because problem statements were many, and if you were a product person, you would not get exposure to problem statements in as broad a swath as if you were in consulting.
Right.
So the big, I have to thank my former boss, employer, entrepreneur. His name is Rangarajan Vasudevan. So he founded a company called the Data Team. I had the fortune of being part of that outfit for about 3.5 years. That was a formative phase, I suppose, in my career as a data scientist, as a data science practitioner. And fast forward to 2018, 2019, we were talking about deep learning, language translation. Microsoft had smashed some benchmarks back then. And fast forward to 2019, we saw the early GPTs, and OpenAI, from OpenAI Gym back in 2016, 2017, had graduated to something more sane, something that's recognizable now with attention and GPT-2 and all that. And then fast forward to 2024, we had GPT 3.5, GPT-4, and all these revolutions, right?
What's that famous paper that everybody quotes? Attention is
all you need. Attention is all you need. Yeah, that's the paper.
Right.
Yeah, Ashish Vaswani was the author of the paper. Yeah.
Well, yeah, you say agentic AI, right? What is the mental model that a business practitioner would want to have about agentic AI?
It's a very good question to kick our discussion off. When we look at AI for the last 10 years or so, the general pattern has been, can we learn from data, right? And when we look at agentic AI and its precursor, generative AI, in the broader AI landscape, they refer to the ability to generate data rather than only use data to discriminate between certain conditions or certain other conditions, or certain patterns or certain other patterns, because that is the discriminative field of AI.
Right.
So there are two broad paradigms within AI, which is discriminative AI and generative AI. Discriminative AI being classification models, like this is a cat versus this is a dog.
Yeah.
And generative AI being a paradigm where you generate data, you generate text. And agentic AI, coming to the question that you asked, is a paradigm where I don't merely generate data, but I generate instructions that can be executed. I generate, I'm not just able to generate data, but I'm able to execute on my domain as well. Right. So that's a stark difference. If you think about it, we are not dealing with the information layer of things anymore. We're dealing with the action layer of things.
It's more like the end user is having the system adapt to him or her.
Yes.
And it's not the other way around, right?
Yes, it's the end user's preferences, their notions, their thoughts, their ideas.
Right.
All that is being processed by the agent so that the appropriate action can be taken.
Right.
When you speak to a Claude or a Chat GPT or any other AI model, as of today, you can sometimes see a thinking flag that comes up over there. It says thinking or reasoning or please stand by or something like that.
Right.
So what's actually happening there is it is performing an iterative task of generating a plan, executing on the plan, or preparing something based on the plan and iterating on that plan so that it can give you the answer that you want.
Right.
So that capability is quite new to models.
Yeah, if you look at it, it's a huge paradigm shift, right? If you were to relate, how a mouse basically redefined GUI, here you have agents kind of redefining the experience from the standpoint that you're looking at users' intent. The interface is more about intent rather than I'm using the platform, right? You're
correct.
You're asking the platform to do something.
Absolutely right. In the past, before we had generative AI chatbots, there were other tools used to build chatbots, right? And things were much more deliberate back in those days.
Right.
I remember the Google toolkit that was used to build chatbots, and I think it was called Dialogflow back then. I think that's morphed and it's become irrelevant and stuff, and now everybody builds with ChatGPT or other LLMs. But in a nutshell, intent understanding was one of the cornerstones of that form of AI.
Right.
So if you went back to 2018, 2019 and you went to an enterprise and you asked them, what would you like to do with AI? Chances are some senior manager would come up and say, can you build a chatbot for me? Right?
Yeah, we heard that.
Yeah. So we all went through that phase where, come on, AI is not just about chatbots.
Right.
Practitioners like us, you worked on large language models for translation.
Yes.
So the score that look, AI is not just about chatbots. Right? There's a whole lot other stuff going on there.
Right.
But for some reason, I think that the idea of a chatbot has captivated
Right.
the machine that speaks back to us. Going back to the days of Eliza, which was the first known chatbot.
Yeah.
Back in the 60s or 70s, if I'm not wrong.
Right.
I could be wrong about the date, but the general idea is the same, that you have some intent understanding, some entity recognition, and some response that's prepared in relation to that.
Very true.
So fast forward to 2026, what's happening is those paradigms are behind us, and we are seeing next token prediction,
Right.
which is the paradigm that these LLMs operate in.
Sure.
LLMs are large language models.
Yep.
So that these paradigm that these LLMs operate in. So it's that next token prediction paradigm that's helping us build not just chatbots, but a bunch of other AI applications, including coding agents, agents for doing all kinds of other business process flows, you name it. I mean, there's a lot of, as you know, there's a lot of exciting stuff happening in this space.
Absolutely. You mentioned coding, right? I think what has taken a lot of prominence is how these agents are helping people code. I was just listening to one of the bits from Andrew from the Davos summit. He was essentially saying how he's seeing the engineer to product manager ratio shrinking from 10:1 to 1:1. I think what you're trying to communicate is that the automation as far as code generation is concerned is like at a very high level. But is the automation around what needs to be built, catching up with that? I think it is still not out there, right?
Yeah.
And so that's an interesting, paradigm that he brought in. So he's basically saying that his team ratio is 1:1 as far as engineers and we are talking about the coders. We will get to the fact that how does the other functional users and business users, how does it look like? But at this point in time, I think one of the point of views is that do people know what needs to be built? How are they arriving at those decisions?
Yeah, it's a great question. I think we're in the era where execution barriers have been broken down.
Yeah.
When I changed careers from quality engineering to data science in 2015, 2016, I had to literally teach myself what the layers of the data stack are, what the layers of the programming stack are, and you had to do this the hard way with no ChatGPT to ask questions to and learn from it. So you had to do this the old way by, number one, maybe reading material related to it. Number two, reading documentation.
Right.
Number three, attending courses or if that's required. And then number four, and most important, practical on-the-job experience.
Right.
So you went through the school of hard knocks to build anything. I think that equation has flipped a little because now, if you want to prototype anything, you can go and ask a chatbot, and it'll do a fairly good job of helping you understand what you really mean, whether that's really sensible, what you're asking for. It'll help you. It might challenge you in terms of certain kinds of things that you've said about what you want the product to be, or what you want the application to be that you want to build.
Absolutely.
So I would say that the execution barrier, once you know what you're doing, has been lowered very well.
Right.
But to your earlier point about is an AI able to replace a product manager, that's a much more nuanced question. So there you're actually talking about something pretty deep.
Yeah.
Right? There you're talking about somebody who's engaging with the real world,
Yeah.
who's looking at real users, and who's able to. So that's what a product manager does, right? They
Sure.
speak to potential end customers or somebody out there who might have a need, and they discover their problem statements. They discover what they have to. So I don't think we're there yet.
So I think it's not about replacing anybody. The way I would probably perceive is that the boundaries of what I would do earlier is probably changing. For example, a designer, right? The designer does not have to come with Figma files today. They'll be actually be able to give you a working flow, right? It's probably just the UI framework, but your business principles are kind of established. What a product manager can focus on is the PMM part of it, which is to go do their market A/B testing relatively faster than what they would do earlier. And then you're now looking at the product manager exactly giving the product team what they need to build, which is gone through the market hypothesis. You're probably coming back one step for the better. But that's another thing, right? I mean, another Twitter thread I was reading. Does that create a standoff amongst teams? You have been having teams, cross-functional teams. How do you see this little intervention working out?
Yeah, I think it's safe to say that product managers, if not now, will eventually learn how to deal with some of the aspects of the code.
Right.
And those who are on the technical side, if you're a 10x software engineer and you already know what needs to be built, and somehow you feel drawn to the problem statements of product, right? You might find yourself gravitating in that direction.
Sure.
And it's already happening. I think that I've come across at least one or two product managers who've been building with applications like Cloud Code.
Absolutely, yeah.
Right, and some of them have been successful. And I think the product managers in this day and age will probably have to see. I won't say that it's a reckoning for software engineers, but it's something like that.
Yeah.
It's something like a reckoning. It's a change in the way they work. Let's put it that way.
We are consciously having our design team members sit through technical sessions. They may be grasping 20% of it, but just going back to the fact that they don't have to have another human being coming and say, hey, this is the concept, this is what it is. Very enthusiastically, they're picking up these things, going back, looking for things. They understand the concept. The chatter on the ground is that they're asking the senior folks, like, what does this mean? I've got it right.
Yeah.
So we are looking at that paradigm shift as well. Our designers want to go give a piece of code as a demonstrable piece. The product manager wanting to go do a market testing a little more earlier, and then you have the product team members just bringing the focus back to the code development debate itself, right? How well is it working? This is a question that I would want to ask you, because I think you have had a larger experience than in comparison to me as to how this is working for a enterprise.
So when you say how well this is working, I want to clarify the question. How well are agentic AI coding tools working for software
engineering? Yeah. I'm glad. Yeah, thanks for clarifying that. I'm just looking at how this is enabling today's tech teams.
Right. So software engineers probably who are okay. So I'll make a distinction here between two different kinds of software engineers.
Yeah.
And we'll talk about in each use case, or in the case of each software engineer or each kind of software engineer, what kind of benefits can AI coding tools give them? Right. So the first kind of software engineer I'll talk about is somebody who's experienced. Right? So even if you say that they are not, even if you don't say that they're about 5 years or 6 years into their career, let's say that they're 3 years or 4 years into their career.
Sure.
Right? So I'm talking about somebody who's like a mid-career professional who's just gotten out of the junior engineering roles and who've begun to look at AI coding tools as of 2026. Chances are they've been in the industry for the last 2-3 years when they've seen the revolution happen. So they know that this is where the puck is moving. So they understand the paradigm shift that's happening, and they've begun to embrace those tools, right? So that's one kind of engineer. Now let's look at another kind of engineer who's probably 10, 12, maybe 15 years of experience, and they've stayed engineers. These are not individuals who have grown through the ranks in their companies. And I don't say that in a bad way. I say that in the way that they have decided to stick to a technical focus for their career. Right? And that's a perfectly, I mean, for the last 10 years or 15 years, I would say arguably that that's been a viable growth path in many companies, not just big software companies, but also medium-sized software companies. Right? So those folks, I think that they might have a slightly harder time, believe it or not, with agentic AI coding tools compared to the freshers or just has been a fresher kind of a profile.
Is that a mindset issue that you're referring to, or is
it's
it
a combination
technically?
That's a great follow-up question, right? So I would say that it's not just a mindset thing. I think it's a combination of mindset with the skill sets that people have invested time in. So people have invested time in the skill set of doing good software architecture, learning how to do clean code, doing test-driven development, behavior-driven development, right? So doing all of these different pockets of, say, back-end engineering, for example, and then on the front-end side, UI and UX, and what the reactive web application of the modern day looks like, and mobile app development, which is another path altogether. So there's all these different streams that people have gone down, right? And they've built specific capabilities in those areas. Now with agentic AI coding tools coming in, pretty much every layer of the stack is being negotiated as something that can be done by agents.
Right.
So what does that mean for software engineers who are experienced? What it means is that they have to focus a lot more on the architecture, on the, shall we say, and this is a precursor to what we might discuss later in this discussion, which is the taste aspect of your application, right? What problems are you trying to solve?
Right.
But we'll get there.
We'll get
the
there.
general idea that I want to illustrate is that if you're too invested in a certain focused area of work, you're likely to lose out from the AI revolution. If you're too invested, if you're somewhat invested and you're there so that you're picking up the essentials, you know how conceptually things work, and you're open to the possibility of automation taking you to a better outcome.
Sure.
So that is the situation where you're likely to succeed and benefit from AI.
I'll just give a couple of my own experiences, right? I'm not talking about the 15-year, 16-year-old, engineers. I see that people who have had, let's say, 8, 10 years of experience, the way they use any of these tools is more pragmatic in their approach, in the sense that they're just not there to pick up code. They are there to, put together a well thought, requirement, and then you have a logical code that is coming in. It's just not about cutting time. And vis-a-vis some of the young, chaps who have joined us, for them it's always about, hey, I'll finish my task faster, which inadvertently has introduced a lot of technical debt into the system. So it's a fine balance, right? What we are doing effectively, within the teams here, and then you may have your, some advisor on that as well. We are encouraging people to use these tools, but we are also, telling them that you have to, understand the code. We have seen many times people don't understand the code. For them, it's the fact that okay, the functionality is working, right? So we've had huge refactoring, sprint cycles. So I think somewhere in the middle you have the answer to this.
Yeah, you're not wrong in saying that it's somewhere in the middle.
Yeah.
I think what's happening here, and I spoke about it when we were talking privately, it's an accountability shift.
Right.
Right. And the accountability shift I'm referring to is the agent accountable for results here? It's not. It's ultimately just a tool. It's the human who's held accountable for results, right?
Yeah.
So when you bring that into the picture, right, the whole picture flips a little bit, and you start seeing these tools for what they are.
Yeah.
So we might have certain notions that are being spread around in the marketing literature from all these big labs, from agentic coding tools and so on, saying, look, this can 10x your productivity. This can this can complete an app in 1/10 or 1/50th of the time. The question you got to ask yourself is the time and energy that you're spending that much of a barrier for you in the current state?
Very true.
So what is the trade-off? Is the trade-off quality versus time?
Yeah.
Or is it something else?
That brings another stakeholder here, right? Normally startups would want to say stay agile, bring out something quick and dirty. Now how dirty is dirty, right?
That's a very good question. So I've been hearing takes on this on social media that are along the lines of we used to talk about clean code, we used to talk about clean architecture, we used to talk about building large-scale data-driven applications with all of these nice patterns, elegance, and so on. And now we are settling for AI slop. And we are okay with AI slop as long as it works, right? So there's many weird illustrations and funny illustrations of how vibe-coded applications work, and how they may or may not be the best thing. So I think often these things are talked about in a condescending fashion, where you say that, look, an agent can sometimes put out slop, and somebody who's using an AI tool to code, they're probably okay with that slop. But I don't think that's quite the case. If you see a senior engineer like the one that you mentioned, somebody with 8 or 10 years of experience, who's got an accountability question to answer, right? So when it comes production deployment day and something breaks, you know where the puck is going to move, right? You know who's who has to save their skin, and that when that question becomes clear, right, then the position of these tools in the context of the broader software development workflow, that becomes clear, right? So they become seen as not the be all and end all of software development, but actually just one of the stages in a broader cycle that leads to a functioning product. Right.
One of the things that we are doing is that, at least we want to implement this. We would want to have, let's say, an hour and a half session every week where we give a problem, what people are required to actually code that without having any sort of tool. Now, why are we doing that? It's not because we don't want to have a agentic assisted programming culture, but it's because we feel that the crux of logical thinking for a engineer would probably go down. I think a lot of people will have counter views on this, but we would want to still inculcate that aspect of it. Taking one more step back, stressing on pseudocodes, understanding what we are trying to build, even before we go into development. Some of the other measures that we are having, but I don't know what your thoughts are on this particular thing. Will it make me less an engineer if I go this path of just using agents?
It does not make you a less of an engineer if you already have the foundation. So to that point, you're right that creating that foundation of knowledge, that foundational knowledge, the bedrock on top of which the rest of your knowledge is built, that's crucial. And if you're not, the space is fast changing, right? So something that I might say today might not be relevant 6 months from now. Having said that, to prefix what I'm going to say, I will say that you cannot only use an LLM or an agent to come up with a system architecture as of 2026, and it's going to be the case for a while. I'm saying that again, as I said, cautiously, because there is, and this took a lot of, there was a lot of buzz around context engineering around 6 months ago, and I think justifiably there's a lot of hype around it even now. Context engineering is this activity where you prepare the field so that an agent can come and execute. And preparing the field could be in the context of many things, including planning or ideating an application. So when you say that I want to build in my engineers the intuitions that allow them to become great engineers in the future, the question really is that the correct incentive to have? Given that agents might even get to that point 6 months from now or a year from now, right? So this goes back to what Dario Amodei was saying. He's the CEO of Anthropic. You're saying all code is going to be written by agents in 12 months, right? I think you can make the case for some of that code being slop, or even a large part of that code being slop. But I would say that the mode to shrinking, right? So the mode to shrinking in terms of what agents are able to do today and what they will be able to do in the future. So the human, if you put the human on one side and say these are the human's capabilities, whether it is sample efficiency, which one of my friends likes to talk about, and there's also a number of other capabilities that humans have, which is the real world context that we inherit and so on. There's also agents which have a digital context. So engineering these contexts can enable the agents to become really effective, even at some of the tasks that we call planning. Having said that, I still think that context engineering is an art and not a science. So it's not like it's a magic silver bullet or the panacea to solving all the problems that agents are not good at today. So to that extent, the human is still involved in pretty much every part of the software engineering life.
We are still talking about all of this from a software engineer's perspective. Extending this same thought to, let's say, some other field of science.
Fair enough,
if you were to use any of your transformers today, to just say, let's say I'm going to go sit and design a very complex system, right? The engineer is having everything on the table, fair enough, but is the person going through the grind of actually understanding what specs are and then building it to the specs, rather than, so again, where's the balance? It's a philosophical question, but
so I assume that you're asking about people who are not software techies, who are maybe experts or engineers in some other area, or technical professionals in some other area.
Correct.
Right? Or they could even be functional professionals, like somebody who's writing a book or generating content for a podcast like this one, right? So it's a great question, right? So I think the broader thought here that you're asking is, can agents really do a lot more than just coding, right? And can they do it well? So I'll take us back.
Yeah. In that context, if we are emerging towards that bit, right? But when that happens, what happens to the engineering, context engineering that you're talking about? What happens to the human being and his intellect in crafting something, right?
Yeah.
You're talking to me about the turbine, right?
Yeah.
So such kind of cases.
Let's talk about the turbine, right?
Yeah.
I want the viewers to get a sense of that example.
Yeah.
I think one of the most iconic airplanes to have been built in the last 100 years is the SR-71 Blackbird.
Right.
And for a long time, the engine that was used in the SR-71 was kept a secret. I mean, I was making the comment in passing that even if you have the full blueprints of the engine,
right,
and a lot of other details that are associated with that engine, it would be hard pressed to find a team of human engineers who could put together that engine for use in 2026, right? And you could make the same argument about, say, the Saturn V.
Sure.
Of course, we can build new systems. I mean, Starship is an excellent example of a new system built by modern engineers with modern tools, and that has done countless flights and so on and so forth. And then taking us back to the J58 or other kinds of complex systems, right? Even if you have the blueprints, there's a lot of human tribal knowledge.
Right.
And what we used to call human tribal knowledge in the context of traditional engineering teams is, in a way, context engineering is trying to solve that problem for agents. Right.
The tribal knowledge is a particular section that we will come to. But as I was just trying to add this perspective. There are views and counter views, of course, but we're all kind of learning. One anecdote that our research team just has made a point. Okay, I mean, I just want to bring this up. This is a conversation between Andrew and Boris.
Boris Cheney.
Yeah. So a very interesting conversation. Like Andrew is putting up saying that look, there is sloppiness and whatever it is, and Boris basically saying I know that, and he's saying look, 100% of the code that I write is through agents. I don't write piece of code.
Yeah.
And there is there's my team which is probably doing 80% of that. But another he extends this and says okay, even any sort of a refactoring has to happen. The agents do it. Of course, he has the necessity to say, look, Claude Code is up there, it can do a few things, but that's in a way a reality too. That any inefficiencies or any debugging that has to happen also can be passed through the same loop, right?
It can be. It can be, and you made a good point here. Agents are not meant for specific parts of the workflow, but for the entire software engineering workflow.
Right.
Excuse me. And that includes refactoring. So I say that because that's an important distinction here. It includes refactoring, it includes configurations, it includes deployment pipelines,
right?
It includes infrastructure, right? So when you have infrastructure as code and you can have agents write code for you,
right,
then infrastructure becomes something that can be set up through agents, right? So you can literally prompt an AWS server into existence, right? And that's par for the course in the current state of how things are going. So to your earlier point about how different people use AI agents, you mentioned Boris Cheney and Andrew Ng having a conversation back and forth. The thought I had there was that the further lower in the stack you are, the greater you might need to write your own code or meddle with your own code. I say that also in the context of low resource and high resource languages.
Sure.
Not all languages are equal.
Right.
Not all agents are trained in the same way. So a Claude might be
That's a fair point,
might be trained better on certain high resource languages.
Right.
And then there may be some specialized LLM sitting inside some company's servers, you never know, that's been trained on Zig, or that's been trained on Rust, or that's been trained on some very specific languages which don't have as big a currency as a mainstream language like Python. I mean, Rust in every sense of the word is a mainstream language. Even the Linux kernel has been debating adopting Rust, and they've successfully done so. But the point I'm trying to make is that between low resource and high resource languages, there's a difference. And between builders who are at high levels of abstraction versus those who are at low levels of abstraction, there's different levels of use that you can foresee
Sure.
for AI agents. I think that even this will be negotiated. I think what's happening is, if you've heard of the term greedy machine learning, greedy machine learning is where you try to find every niche and you find a solution for the model in that niche, right? So the so-called XG boost in the tree models of the world, back before LLMs became a thing, they were the OG of decision tree based machine learning. For a long time, those were considered very efficient learners because they're greedy machine learning systems. And I think that at some level, the meta system that is building agents for us right now. When I say meta system, that includes the labs like Anthropic and OpenAI and what have you. They are greedily approaching many problem statements across the space, whether it is the tech space or the non-tech space, content writing, etc. Right?
I think that sets up for a separate conversation itself. There's a lot that
there's a lot that we can talk about.
So in one, I'm probably trying to close this conversation now. Vibe coding. Everybody's talking about vibe coding. How many times would you see the vibe coding being applicable to large, complex production systems?
Yeah, that's a great question. I've been vibe coding for the last year and a half, I would say. And I've been using it for a number of open source projects.
I would want to clarify this as well. I mean, vibe coding, again, there are two set of people who can do vibe coding, right? One, these are software engineers who know what they are doing. The other section would be people who are not essentially software engineers. I'm just talking about the software engineer folks at this point, because I think vibe coding from let's say business managers and functional managers is a little different.
That's a little different. Yeah, fair enough. That's a good distinction. So sticking to vibe coding that is done by software engineers. I think the earlier question, the original question, if I'm not wrong, is how do you expect vibe coding to be used by software engineers?
And while what is the extent of its use while crafting complex systems?
While crafting complex systems, so I guess that's the distinction. So with the software engineers, you can say that they already have intuitions about or experiences about what systems are going to be built like, and the process from when they have a set of requirements to the process to the deployment of the application. Assuming that they are full stack engineers, they have the entire visibility or they have understanding of the entire flow from the start to the end, right? And not all engineers are the same, but you can expect that if they know a certain portion of it, they can figure out a certain other portion of it. Right? So if I'm a backend engineer and I have some exposure to front ends, I can, with given enough time and patience and interest, I can figure out the front ends and so on. Right? And that used to be the pattern. So coming back to how agents are going to be used here, the difference between a large code base and a small code base, let's look at that, and from that I'll build up to the answer on how these engineers could use these. Large code bases have very often a lot of abstractions. So the thing about abstraction is fundamental to all computer programs, right? And for decades we've written many different computer programs in very large systems like OS kernels and so on and so forth. Would I say that AI agents could be let loose on any of those large code bases and can make changes to them? I think the chances are somewhat small. The reason I say that is, like I said, abstractions, the sheer number of abstractions that there are and the many variations of the abstractions that there may be in large code bases, that is one point of challenge, I would say, to agents. Another is the duration of certain tasks, right? Agents, it's been known in the recent past that some agents can be made to run for days to generate code, write tests and bug fixes and what have you. And there's also the concept of work trees, where you divide a big feature into multiple small parts, and then you have multiple work trees running for Claude or whatever to generate code for different portions of the feature and then merge everything together, right? So all these are viable ways in which to approach this kind of issue with larger code bases, but there are some limitations in terms of how such a large code base can be addressed. One is the limitation of the model itself. Not all reasoning models are created equal. Not all code generation models are created equal. We have and I think I attribute similarities in how these models appear on the face of it to what's called benchmarking. This is an unfortunate problem in the space of LLMs and in how the labs talk about their models.
Right.
And when I say it's unfortunate, it's because of the fact that the benchmarks themselves become an objective rather than a means to an end. When you train an LLM to do agentic tasks, it goes through several steps, several individual stages in the training process. There's unsupervised training that is used to train the bulk of the model for next token prediction. Then there's supervised fine tuning, and then there's alignment, right? That happens with reinforcement learning or other policy gradient optimization methods, right? In a nutshell, not to get into too much of technical detail, I would say that the way in which each model is trained is different. And if you're expecting the benchmarks to look the same for all models, regardless of how well they are at specific tasks, then you're backing up the wrong tree. You should be, in fact, testing out models and looking at the vibe of the model. You're looking at the feel of the model, because that's, in my experience as a vibe coder or an engineer who's built applications using agents, it's a much better signal. It's a much better signal. It gives you much better signal in terms of how good a model is going to be for your specific task. So these are some realities around the model.
No, we'll certainly get a lot more technical in our following sessions. We'll certainly set it up that way.
If I were to touch on just one more point,
Yeah, sure.
in terms of what might affect agents and how they're used in large code bases, it's the nature of the agent's design itself.
Sure.
And whether it's a multi-agent system or a single agent system. Right. I think software engineering, as I have found out, is a certain kind of task where having an agent and sub-agent pattern is quite effective. Right. And I sort of learned this by building Praval. And
so for our viewers, I was waiting to bring that point. Rajesh has been building an agentic framework himself. It's called Praval. We'll leave the link here as well as in our resources. People are welcome to actually use it. Very nice of him to have open sourced it, and he's continuously working on it. And again, there's a lot of philosophy in the name itself. Praval. It's like how the coral reefs are structured. So you could give a little bit of purview into it now, and then we'll have a session on Praval another day for sure.
Thank you so much. Thanks for talking about Praval. Praval is an agentic AI framework that is inspired, as you said, by coral reefs, and that did not come by accident. It comes from the experiences that I have had with multi-agent systems in the past, and it also comes from the need to build software where you can build agent swarms that can solve a lot of complex problems through self-organization. And self-organization happens when I believe that certain things fall into place. One of them is agent-to-agent communication is a native capability of multi-agent systems, and that should be present as such. The use of tools should be native to agents, and it should be easy to set up and run agents as well as tools. Knowledge is another fundamental thing with agents, knowledge and memory. So you'll find that with Praval, which is a Python-centric AI framework, agentic AI framework, these things are addressed. You find a simple decorator pattern for invoking agents, for invoking tools. Agent-to-agent communication is a first-class citizen. It's made possible through something called Reef. Again, that's a reference to corals. It's an abstraction whereby an agent can send a message to the Reef, and that's picked up by the agent that's going to be concerned with that type of message. So these are typed messages that allows you to separate flows and contexts in ways that other agentic frameworks cannot. And in general, and although you can build it in another way, in general, my pattern, the recommended pattern that I have is completely distributed agents that do any kind of handoff or any kind of pass of the specific message that they want to send. Of course, in practice, this converges to a few patterns, but in Praval, so far I've built a number of applications without having a manager follower or a leader follower kind of pattern, right? So there's an application called Praval Deep Research, which your viewers can also take a look at. This is a local first research tool for researchers, for people who read papers on archive, especially. and who want to chat with the paper.
Okay.
They want to chat with the paper, and all of these are Praval agents working under the hood. You can chat with the paper. You can post about the paper on social media by using summaries. You can use research with citations and feed off of that and do other kinds of workflows for yourself. You can do a number of complex things with knowledge base, and there's also a lot of context engineering I've built into that by way of a research agent that looks at all of your research areas by understanding the base of papers that you've built up, especially if you have a large number of papers. It's very effective in figuring out and nudging you in the directions that you should look at. So that's an example of an agentic flow that's enabling you to do your research better, right? So this might be interesting for those who are.
Certainly is. We are using it as well. I mean, the team is looking at using Praval for specific use cases. So yeah, I think we should have one session around that, and I know you are progressively adding to it. So it'll be good if you could come on another show and then talk about that as well.
Absolutely, yeah, I'd be glad to.
Cool. I'll just probably bring a close to this section and then move on to the what I believe will be the greatest benefactors of AI, which is essentially non-technical professionals. When I say non-technical, I'm talking of people who don't understand software engineering.
Absolutely.
And we will talk about that.
Yeah.